Hello, everyone. I hope you're all having a great week. Before we get into the lab, we have a few little logistical things to cover. First, you have your second lecture exam this week. Just make sure you know about that and are thinking about it. Don't forget that those are synchronous, so you have to be there. And then the second point is that we have our lab midterm coming up on either October 13th or 14th. Again, that's synchronous, so make sure that you'll be available then. If you won't be available then for whatever reason, you need to reach out to me as soon as possible so we can try and arrange something else. I should be releasing a what you should know sheet or study guide later this week for the lab midterm. So keep an eye out for that if I don't release it with this video. I think that's everything logistical we need to cover. So let's hop into the lab. And we do have a PowerPoint this week to go over. Sorry, that is the end. Let me hop back in. All right. So lab 6 is on volcano forms and process. And here I am at the volcano Kilauea on the big island of Hawaii. And we'll talk a little bit more about Kilauea later. So as some early background, it's important to know that volcanic landforms are the results of extrusive and shallow intrusive igneous processes. So they're most directly related to igneous rocks and those sorts of processes. And they're also related to the shifting of tectonic plates. One example of that you can see here in the picture above with a subduction zone forming volcanoes. Second, we'll talk about magma characteristics. It's important to know that magma is under the Earth's surface, while lava is the liquid form of magma extruded or above the Earth's surface, and tephra is magma extruded in its solid form above the Earth's surface. Also, it's important to know that viscosity is a measure of how easily a fluid will flow. So there are two types of magma we're going to be talking about: a basaltic or mafic magma, which has low viscosity. This means it flows more easily, and it has relatively flat flows because of that. Then there's felsic magma, which has high viscosity. And because of its high viscosity, felsic magma will clog volcanic vents, and this allows pressure to build up until eventually it explodes. And this is what causes explosive volcanoes in general. So those volcanoes are generally characterized by steep-sided slopes, and a lot of times you'll be able to see ash and cinder. Now we're going to go over the 4 important volcano types for our purposes. The first one is a shield volcano. These are characterized by basaltic flow. The volcanoes have broad, low-angled slopes, and they're associated with effusive eruptions. One example of that is Kilauea, which I showed you the photo of me with earlier, and here's a photo here, sort of a larger view of that volcano. And that's sort of a standard shape with that broad, low-angled slope for a shield volcano. So our second type are composite or stratovolcanoes. These have alternating layers of tephra and viscous lava. They are steep-sloped and conical, which you can see here in the photo, and they are associated with explosive eruptions. So sort of a famous example of a composite volcano is Mount Vesuvius. And the famous associated eruption is the destruction of Pompeii. Our third type that we're going to be talking about are calderas. So calderas are large depressions, and they're usually formed after a volcanic eruption when a volcano sort of collapses in on itself. And one example of that you can see here is Crater Lake. Then finally, cinder cones are our last type of volcano we're going to be talking about. So these are formed primarily of tephra, and they're dominated by ash and lapilli. And generally, these are smaller than shield or composite volcanoes. They have approximately symmetrical cones, and they're sort of shaped by the angle of repose. And so what that means is it's how steep a slope can be, where loose material will lie without sliding down under the force of gravity. And one example of that is Cerro Negro, which you can see in the 2 photos here. This is a volcano in Nicaragua. And you can see that it's sort of, again, dominated by this ash and these small volcanic rocks. And you can see that it's a lot smaller than some of the volcanoes we were looking at before in general. Okay, so that's everything for the PowerPoint. Let's switch over and look at the lab materials themselves. Sorry, this might take 1 second. All right. All right, so you should be able to see this now. Again, Lab 6, the background goes more into depth into the things I just talked about, so make sure to read through that. Yep. So we got the basalt flows, the 4 types of volcanoes. Again, make sure to give it another read through, look through it before the quiz. And then for the actual activity, we're going to be working in Google Earth Pro. So of course, you're going to want to open up Google Earth Pro, set these settings, make sure everything looks right. And then what you're going to go through are 4 volcanoes at first, 1 of each of the major types. And we'll go over Mount St. Helens together right now, so that hopefully you don't have to go back and do too much work to write down those numbers. You're going to record a bunch of measurements about these volcanoes. You're going to take some descriptive aspects of them. And then at the end, after you go through these 4, you're going to fill out this table and talk about some of the characteristics that define each of these 4 types of volcanoes and how they're evidenced by these example volcanoes. And then you have a 5th volcano that's a mystery volcano. So you're going to take all these same sorts of measurements and descriptions on this volcano, and then you're going to kind of guess, based on that evidence, what its volcanic type is. After that, you will go read this article, which involves that volcano, and get a little bit more information about that. And of course, as per usual, your grade for this week is a quiz on Blackboard. It will be due, as always, at 11:59 p.m. this coming Sunday. And so that's everything we need to know for the lab materials. So now let's sort of switch over, talk about Mount St. Helens, so you have an idea of what you'll be doing during the lab. All right. So now we're looking at Google Earth Pro. And I've already taken it to the coordinates given in the lab for Mount St. Helens. But of course, you already know how to do that. You just put them in the search bar. So the lab asked for a few different measurements on Mount St. Helens. There are 2 probably easy ways to do this, depending on what you want to do. And it's important to remember that this lab isn't about getting exact, precise numbers. It's about general estimates and kind of getting a feel for these sorts of things. So don't worry if you get a little bit different numbers, or if you want to be more precise, you can average them out across a couple of different examples, but it's not too important to get everything exactly right. So the first thing, or one of the measurements it calls for is, actually before this, it calls for the elevation of the top of the volcano, which you can get sort of by moving around and looking down. So it looks like maybe around 8,000 feet from Mount St. Helens. And at the base of the volcano, which might be around here. So it looks like maybe around 4,000. Again, it can be kind of hard to tell where the base is, but we don't need exact measurements for this lab. So then you might want to measure the diameter of or the width of the crater. And so you might click there and click there. You don't necessarily need to look at the elevation profile, but if you'd like to, you can. So if you're under line, you can do this. Let me clear this out. So you can either look at it at the line like this. There we go. And see it's about 2 kilometers. And then maybe you want to measure the base of the volcano. So maybe you might say it's about 8.5 kilometers. If you want to try it from another side to get a different angle, maybe there it's again 8.5 to 9 kilometers. You can average a couple of these measurements out if you want to be more precise. And another thing, if you want to do it in a different way, is to do it as a path with an elevation profile. So if I click around here and bring that path across the volcano, here you can sort of see the shape of the volcano with an elevation profile. You don't have to do this, but if it's helpful to you, then you can see, okay, yeah, it is around 7,500 or 8,000 feet, at least on this side. And this is, of course, just one line through the volcano, so it won't necessarily show the highest point unless your line includes that. And then, you know, maybe around 4,000 feet for where this volcano starts to level off on this side. Because it's Mount St. Helens, it's missing a side, so you probably don't want to do your measurements with this side of the volcano from the large eruption. But those are sort of your measurements. The rest of those are calculated off of those measurements. And then looking at some of the descriptions, if we want to change our view angle a little bit, we can see that this is a pretty steep cone. So that's probably the shape we would use to describe it is, sorry about that, is steep. And then in terms of the magma, or we can see, or the flow, we can see that it's lighter colored. If you zoom in, it looks a little more ashy. So we know it's felsic and not basaltic. And then from those two factors, and based on our own knowledge about Mount St. Helens, we can guess that this is probably a volcano with explosive eruptions. And that's pretty much confirmed by the missing north side of the crater. And then the last question asks you to zoom out, take a look around, and try and guess at sort of the tectonic processes going on. So you can see that there are a lot of different volcanoes that dot the landscape. And then if you look at the ocean, you can actually see the subduction zone here that's forming. So that gives us a good idea that this is a converging tectonic plate, which is forming a subduction zone. And those are sort of the main answers you need to have for each of the volcanoes. First, one of each type across those four, then your mystery volcano. And make sure to get ideas of how to identify volcanoes by type and what sort of characteristics you're looking for, because you're going to have a couple questions in the quiz, or you might, where you have to look at a picture of a volcano from Google Earth Pro and say, okay, what type of volcano do I think this is based on what I'm looking at here? So get a good idea for those sorts of shapes and characteristics of those volcanoes. That's everything for this week. Again, make sure to take the quiz for this lab. Make sure to take your lecture exam this week, and make sure to start thinking about getting ready for the lab midterm next week. All right, thank you everybody, and have a great week.